Distinguished guests and speakers, ladies and gentlemen, a pleasant morning. Welcome to the first day of the Geographic Information System, or GIS Workshop 101. This event is brought to you by the Urban Design Studio Laboratory of the UP College of Architecture. This is a three-part series of learning events on GIS scheduled on March 10, 15, and 17. To formally open our webinar is Professor Rosario Barria. Prof. Barria is an assistant professor at UP College of Architecture and a professional architect with more than 20 years of experience in residential, commercial, institutional, and community architecture. She specializes in architectural lighting, urban lighting, and co-designing. She holds a master's degree and bachelor's degree in architecture, both from the UP College of Architecture. Currently, she heads the UPCA Urban Design Studio Laboratory. Without further ado, let us give the floor to Prof. Rosario Barria for her welcome message.
Good morning. The goal of the global community to plan and propose ideas, theories, systems, and designs for climate action is evident now, and has been so for the past half a century. Climate action means to take urgent action to combat climate change and its impacts. This is Goal 13 in the 17 Sustainable Development Goals of the United Nations. The amount and kind of destruction climate change are creating are different in different parts of the globe. For some, it may mean stronger typhoons, heavier floods, hotter days, and sea levels rising. For others, drought and food shortages. According to UN's climate adaptation, a $1.8 trillion investment in early warning systems, climate resilient infrastructure, improved agriculture, global mangrove protection along coastlines, and resilient water resources could result to $7.1 trillion earnings from a combination of avoided costs and a variety of social and environmental benefits. The recent Glasgow Climate Pact called countries to increase their financial support to developing countries in adapting to impacts of climate change and building resilience. It established a work program to define a global goal on adaptation. It identified the collective needs and solutions to the climate crisis already affecting many countries. The Philippines, considered as one of the most vulnerable, has remained devoted to the global call for climate action. With the ratification of the Doha Amendment to Kyoto Protocol in 2016 and the Paris Agreement in 2017, it has focused on improving or promoting energy efficiency, improving transport systems, shifting to cleaner fuels and vehicles, improving solid waste management and wastewater treatment, ensuring forest protection, restoration and rehabilitation, and adopting climate-resilient agriculture practices. The Philippines has been a witness to the effects of climate change, with the most recent onslaught last December 16, 2021, of Super Typhoon Rai, or local name Odette. It caused 407 casualties and destruction of property, infrastructure, and agriculture amounting to 23.4 billion pesos. Munich Re, a global reinsurer, identified Odette as the second deadliest natural disaster, only after earthquake in Haiti, which is in the top spot in its annual report on natural disasters. This typhoon and other natural disasters brought about by climate change make it really important for us in the design and build industry and in the academe to search for methods and solutions to further our agenda on climate action. It is also noteworthy that one of the approaches that our institutions and cities in the Philippines are advocating is the metropolitan discipline. Metropolitan planning is a co-created interdisciplinary approach to planning for our metropolises. Since these are major economic drivers, where 46 of the 100 combined metropolises and economies are actually metropolises due to their efficient operations and GDP stopping other countries, They will have to be studied and planned systematically and rigorously. Since the problem of climate is tied directly to urbanization, the amount of carbon footprint our cities and metropolises generate, our metropolises will also have to participate in our agenda for climate action. In all these, there are many methods that aid in planning and urban design. For our special event today and in the next two sessions, our focus will be on GIS or Geographic Information Systems based approaches in site planning and in metropolitan planning. GIS is a very user-friendly and powerful tool in mapping, data collection, and in processing and visualizing data. With so many avenues for research and applications, the knowledge of GIS shall enable students and professionals alike to efficiently adapt the program and make it second nature to them in conducting digitization of information and big data analysis. On behalf of the University of the Philippines College of Architecture, the Urban Design Studio Laboratory, and Extension Office, welcome to our GIS 101 workshop. We are fortunate to have with us our guest speaker, Dr. A.E. Mallari, and workshop conductor, Miguel del Rosario. For the next 3 sessions of the workshop, they will walk us through the basics of GIS and teach key site planning techniques and GIS applications with emphasis on climate, disaster risks and vulnerability, and flood hazard assessments. I would also like to thank the support of our Dean, Dr. Grace Ramos, and members of our organizing team, Professor Aaron Lectrones, Professor Ana Caraan, Pura Vea Valle, and our UPIS interns for making this event possible. Good day and welcome.
Thank you very much, Professor Rochelle Baria, for a warm and inspiring welcome message. In today's webinar, we will have a basic introduction to Geographic Information System and an overview of Geospatial Technologies. Our first speaker is Dr. Alyosha Ezra Mallari. Dr. Mallari holds a PhD degree and a master's degree in Urban and Regional Planning and a degree in Bachelor of Science in Industrial Engineering cum laude, all from the University of the Philippines. As a licensed urban and environmental planner, Dr. Mallari has provided consultancy services to numerous projects in the fields of resource and impact assessment, land use planning, disaster risk preparedness, policy review, among others. He has also presented at international conferences featuring his various research works on climate change vulnerability and land use assessment and planning. His academic and professional interests and advocacies include Geographic Information System, Spatial Analytics, land use planning, climate change vulnerability, and risk assessment. Let us now welcome Dr. Alyosha Ezra Mallari for his lecture on Basic Introduction to GIS.
So, hello everyone. I am Dr. A.E. Mallari. Today, I will be giving a short introduction to GIS or Geographic Information Systems and also a bit of spatial analysis. So, I am an urban and regional planner by profession. I finished my degree here in UP in the School of Urban and Regional Planning or in UP SERP. I've been a consultant for different planning projects before, so I will be sharing some of my experience in the class today. My academic and professional interests include spatial analytics, land use planning, the use of geographical information systems, climate change vulnerability and disaster risk assessment, land use simulation, among many others, no? So from what I understand, this is the first part of a 3-session module on GIS, no? So later, my colleague, Sir Miguel del Rosario, will be teaching the basics of GIS, no? Okay, so this will be the outline of my presentation today. First is I will give an overview of GIS and spatial analysis. So it's a very short overview. We will discuss the definition of GIS, what are the different software being used, and also how is location data being used in our daily lives. And then next, we will check what are some of the emerging trends and challenges in the cities in the coming decades. So, as architects and planners, I think this is crucial, no? That we have to know what are the challenges being faced by our cities. And from experience, the use of GIS and spatial analysis has been very practical. So several cities and LGUs use GIS as a way of solving some of their problems, no? And for them to have better informed decisions when it comes to facing these challenges. And finally, I will provide some examples of how GIS is applied in the urban planning sector. So for this first part, it's more of an appreciation. I will share some outputs of what GIS can do when it comes to specific problems being faced by the cities. Okay, so some of these applications include land use planning, transportation planning, mainstreaming climate change and vulnerability, mainstreaming climate change vulnerability and disaster risk assessment, site planning, among many others, no? Okay, so this is a very simple outline of what I will discuss today, and hopefully you will learn from the things that I will share, no? Okay, so for a short introduction, we live in a world where location data is being utilized in a daily basis, no? So, what are some examples? Kayo as students, di ba? For example, you want to post on social media, on Instagram or Facebook or Twitter. There is an option where you can indicate your location if you allowed your app to do it, no? So here in the example, you can see the location of the Instagram post, no? Or maybe you are looking for directions to a certain area or establishment. The common app being used is Google Maps, no? To check where is the location of this establishment that you are looking for. And also, if you're using a car in a daily basis or almost a daily basis, most likely you have already used the app Waze to help you find the shortest route to your destination, no? Now you see that using location data can be very practical on a daily basis, no? Now, there are certain software that can process and analyze these location data on a bigger scale to make better decisions. This is where GIS and spatial analysis come in. We have certain software that can analyze several location data and create outputs that will help stakeholders create better decisions, no? So this is more than just a mapping software, no? Kasi people think that usually people think that the purpose of GIS software is just to create maps, no? So it's more than mapping, no? So in a while, as I've mentioned in my outline earlier, I will show different examples of how GIS is being used in the urban planning sector, no? Okay, so here's the formal definition of spatial analysis according to Esri. So spatial analysis allows you to solve complex, location-oriented problems and better understand where and what is occurring in your world. It goes beyond mere mapping to let you study the characteristics of places and the relationships between them. Spatial analysis lends new perspectives to your decision-making. Okay, so now that we already defined what spatial analysis is, let us proceed to exploring the different tools available for spatial analysis, no? So in our lecture, I think for the entire 3 sessions, we will just focus on GIS, no? Or the GIS software. So the common GIS software being used today are QGIS and ArcGIS. So these are the tools for spatial analysis. After my session this morning or today, so my colleague Sir Migs will teach you how to use QGIS on a basic level. So the main difference between these two software is that, QGIS is free. It's open source, while ArcGIS requires a license. No? But for the purposes of learning how to use GIS, I think Sir Migs will focus on QGIS since it is free and readily available for download. No? So the basic tools will be taught in his module on how to use QGIS. No? But of course, several courses are being offered if you want to take an entire, let's say, course or module on GIS. No? Okay, so the next part of my lecture is let me mention the emerging challenges in cities. Now, as I've said, this is important since as architects and planners, we can use several tools, including spatial analysis, to solve some of these problems that are emerging in our cities. No? Now, let me note that what I will discuss here are just common examples of what most cities or LGUs face. No? This is also based from experience from my projects. Of course, there are a lot of other challenges, but due to time constraints in our session, I will focus on these examples. Okay, so one of the common challenges being faced by cities right now is the lack of proper implementation of urban design, land use allocation, and zoning. So citizens desire to have a better access to public amenities or even to the proper utilization of their land. Now, regarding land use, we ask questions like, should this area be really allotted for, let's say, commercial use or for shopping malls? Or is it better instead to have a public park here? Diba? We ask what is the basis of this area being or having this certain type of land use, no? So bakit yung lugar na to residential, tapos yung katabi naman niya is commercial or industrial? And definitely we've experienced certain problems regarding land use during this pandemic, especially here in Metro Manila, no? We found out the need for more open spaces, for more bike lanes or infrastructure for bike lanes, for sustainable transport. So all of these issues fall into this category in which cities are facing right now. So we've seen that some areas in the metropolis might be too congested, no? And this lead to several problems for the environment, and also our public health, no, is at risk. So it's very interesting how urban planning plays out in having a big role, no, in terms of battling the pandemic, no. So we have to plan better for cities to have for them to have a better urban resilience, no, as planners, no? So we know that cities should allocate more spaces for pedestrian lanes and public parks or open spaces, and zoning implementation plays a huge role. Now later I will show some examples of how spatial analysis can aid in the land use plans and the zoning ordinances of cities. No? Okay, so the next challenge that I will discuss is the access to safe public transportation, no? Which is also kind of related to the first one. Again, we've also experienced this terribly in Metro Manila, whether you are a commuter or a user of a private vehicle. Again, this covers a lot of issues that might take several sessions to discuss. So we also have courses available on transportation planning in a UP SERP if you're interested, or in the National Center for Transportation Studies. But anyway, GIS and spatial analysis can help in solving some of these problems, no? So some of the questions that we might ask regarding this topic is the current supply of public transport units enough to match the demand? Or are the stations of public transport like bus stations or MRT stations or LRT stations accessible through pedestrian lanes? So are there also enough bike lanes in the city, if we're gonna map it out? So mobility is an issue that needs to be addressed when it comes to urban planning. And again, later I will show examples of how the tools of QGIS can aid in improving some components of transportation planning, no? And finally, another challenge that our country or the Philippines also experienced in the recent decades, whether you're a city or a municipality, is the threat of climate change, no? So we've experienced the onslaught of several typhoons that every year, no? It leads eventually to flooding and destruction of our resources, maybe from agricultural resources such as crops, or even to infrastructure, no? To buildings and other infrastructure. So mainstreaming climate change adaptation and disaster risk assessment has been very vital in terms of planning, no, for our cities and municipalities. And again, GIS and spatial analysis play a huge role, no, in terms of mainstreaming CCA and disaster risk, no. Later, I will show examples, no, of how of vulnerability maps and disaster risk maps. So these are a few examples of challenges that cities face. Again, I mentioned that there are a lot more challenges, no, apart from these three things that I mentioned. But these are examples in which spatial analysis and GIS can contribute to, in terms of making better informed decisions. So in the next part of my discussion, I will show some of the tools, some of the extension tools of GIS, so you'd have a better appreciation, no, of how the planning in terms of like land use plans, transportation planning, and climate change adaptation planning use GIS and spatial analysis in order to have better decisions, no? Okay. Okay, so the first concrete application of GIS in the urban planning sector is land use planning, no? So land use plans are a major requirement by the law, which is I think Republic Act 7160 or the Local Government Code, in all cities and municipalities here in the Philippines. So local government units are required to update their comprehensive plans, or the acronym for a comprehensive land use plan is CLUP, on a long-term basis, no? And one of the outputs required for the document is a proposed land use map, wherein the spatial strategy for the city or municipality is shown in different land use categories, no? So for example, certain areas are designated to be residential, some are commercial, and then eventually you translate this proposed land use map into a zoning ordinance, no? So the comprehensive land use plan is a public document. You might want to visit your city. So kunwari, if you live here in Quezon City, there should be an updated CLUP available, no, for viewing. And the comprehensive land use plan is not just a map, no, parang it's an entire document. There's a certain process to be followed, which is the process is assigned by HLURB. So we have a guidebook on how to formulate a comprehensive land use plan, and there are several applications of GIS and spatial analysis in that process, no? So this is an example that you see. As you can see, there are different land use categories assigned. So, to make it simple, no, these maps are processed in the GIS software, no. So to come up with a spatial strategy or a proposed land use, a certain process is being followed, no. Now, GIS in particular comes in a step using a method called an overlay analysis, no. So in an overlay analysis, you have several spatial data. Let's say topography, the slope of the area, the soil data, no, or soil map. You also have the hydrology or the location of the water bodies or rivers, your existing roads or infrastructure, and of course you also have your constraints, no. So usually in constraints you have the slope with high categories, the hazard constraints, and others, no. It depends usually with the LGU, no. And then what GIS does is that all of these spatial data are processed in the software. I think Sir Mix will provide an example, no, of how the certain processes in GIS are being used for the sieve analysis, no. So I think it's a bit there's an intersect function, and then so these spatial data are serve as inputs, no, to the software, and then once you conduct an overlay analysis, you will see which lands are still available for development. So again, the beauty of GIS is that it's very flexible, no. You can assign parameters. Let's say these areas, even though they're residential areas, even though if they're agricultural areas or open spaces, you wouldn't want to prioritize them to be converted into a certain land use, no. So you can designate those parameters in GIS, and then the software will, since it's a software, you just input, or parang it is programmed automatically, no. And then so there are several ways, no, in how the land use plans are being utilized, no. And later I will show other examples of plans that branch out from the land use plans, no. Okay, so in this slide you will see an example of the sieve process, no. So for purposes of illustration, you'll see in this map, you'll see in this example certain spatial data, no, such as, I think this is the alienable and disposable land, and then a map of constraints, and then eventually, you also input other spatial data, and then you'll come up with an existing land use, no. So this is very crucial, no, kasi what happens during the process of formulating this proposed land use is that the stakeholders have inputs, no. So usually you start with a vision, what's the vision of the LGU, and then you'll see the goals and objectives, and also what are the opportunities and constraints, and then you have inputs from stakeholders, and then you also have mainstream other plans, no, into the land use plan then, no. So this is actually a very common example of using GIS and spatial analysis here in the Philippines. In UP SERP, no, you'll encounter many studies involving these comprehensive land use plans, because this is the essence of planning talaga, no, in our cities, since we are on an we operate on an LGU level. That's why the comprehensive land use plan is a crucial document, no. So every time, let's say you want to put up a business in an LGU, you have to check their land use map if it's aligned with their plans, no, and so on, no. So So this is one. Okay. So another application of GIS in land use planning, this is something which has been gaining traction in just the recent years, no? In terms of research, is land use or land cover change simulation. So the studies of land use change also serve as a guide for policymakers in long-term urban planning. You'll see other countries really have research now for the land use change in their cities. And with the research, there has been an emergence of spatial models to aid land use planning. No? So GIS software in particular has also evolved in the recent years in terms of its functionality and power and capacity. So there have been several models of land use change available, no? As you can see in this list. So some include spatial models, optimization models, cellular automata, dynamic models like statistical models, microsimulation, stochastic models, and hybrid models. No? Now, there have been extension tools available in the GIS software that can handle land use change modeling. No? So this is also my field of interest. So for example, in QGIS, we have an extension tool called modules for land use change simulation. No? So this is an extension tool in Quantum GIS or QGIS. So it uses transition probability modeling and cellular automata for its modeling aspect. No? So basically, you can determine the location of the future land use change or land cover change development using the following spatial data. No? If you have data on your existing land use as well as the spatial driving factors. No? So for example, you can input the parameter of the future land use change of residential areas being near existing residential areas or near commercial areas, no? So that they would have access. So that's an example of spatial driving factor. And then the program or the modules for land use change evaluation will run it. If you input the parameters, and then it will generate an output of the location of the future land use change. Of course, there are several assumptions to this tool, but it is already a huge step now because before especially in land use planning, tools like these haven't existed yet or haven't been utilized by the local government units, no, especially here in the Philippines. So this is a very nice development, and it really uses spatial analysis and GIS in this area, no. So another version of the land use simulation tool, this time in ArcGIS, is Land Use Sim. So it's also an extension software which uses the same principles as the modules for land use change evaluation, wherein you have, this time you have spatial determinants, and then you also rank them. You use a weighted, you use a certain point. It's like a point system wherein you allocate which spatial determinant is the most influential in terms of development. So the same principle as earlier, you know. For example, you want to set parameters for the future residential development. It must not be near industrial areas. It must be near accessible roads and also existing residential and commercial areas and institutional areas. So Land Use Sim is another version of a tool for simulating land use change, and the spatial determinants have an influence on the next location of the land use growth. No? So I think the difference is this you need to pay for this software, unlike the extension tool for QGIS. So there, no, these are just a few samples, no. There are actually a lot if you look at the different researches on land use and land cover change simulation. And it's very practical since we, as planners, no, and also as architects, we want the development or the future developments of land use to have a basis, no, a proper basis, no, on allocating why is this residential instead of like an industrial or institutional area. So we have to have proper basis, no, and these tools help in the decision making, no, of the stakeholders and those in the government. Okay, so apart from land use planning, GIS can also be used in other levels of planning, no, such as site planning and master planning, which is I think you are more familiar with. So it uses the same principles and same tools, no. I think, and yeah, from experience, I know the shape files or the geopackage files can be converted into a CAD format, no, so we can use for your AutoCAD. So technically, if you do master plans or site plans, having a knowledge in GIS is also handy because you will use a lot of location data. So it's better to if you learn both AutoCAD and GIS, no. Okay, so the next application of GIS is transport planning, which I also mentioned earlier. So in transportation planning, this is a very interesting field also, and it also has gained traction in the recent years in terms of research. So both QGIS and ArcGIS have extension tools that can analyze transport data, no? So the familiar one, which I will discuss today, is the Network Analyst, no? It is an extension tool of ArcGIS. Actually, QGIS also has a Network Analyst extension tool. And this extension tool provides a wide array of options that you can use to analyze transport data, whether it is road data, accessibility data, traffic data. But as an example, maybe I'll just illustrate this one. So this is an accessibility map. Basically, accessibility analysis is important in the context of transit-oriented development. So when we talk of transit-oriented development, the mass transit stations must be accessible to pedestrians because that's a concept that we push for, no? There's a mixed-use development, and then all of the mass transit stations must be accessible to the pedestrians. And the accessibility analysis helps, no, in determining which of these stations have better access, no, to the people. So for example, what the network analyst can do is that it can create a it can create a service area, no? So that's what we call it, a service area, in which you input the station coordinates. For example, whether for ArcGIS or QGIS, it applies the same principle. And then it can calculate the shortest distance, no? Or the shortest route from that point. So what's the implication of this, no? Okay, so for example, we want to know which areas of this road network is accessible to that station via a 3-minute walk. Of course, we have certain assumptions, no? Kunwari, our assumption is that the average walking speed is 4.2 miles per hour. So let's say we want to know which of these pedestrian lanes are accessible to this certain mass transit station, no? So that's where network analyst comes in, no? It can calculate the service area output. You just input the road network and the point, and also your assumptions, no? The walking speed or the distance. And then it can generate an output which is easily visualized, no, by people, no? So here you can see an example, no, which among which parts of the road network have access to the station in different time intervals, no? You have 3 minutes, 6 minutes, 9 minutes, 12 minutes, 15 minutes, and so on, no? Of course, again, there are several assumptions here, but what I like to demonstrate here is the power of the tool, because this data can branch out into several research ideas, no? For example, you want to know what are the land uses in this road network, no? Because yun nga, if we're pushing for transit-oriented development, you must optimize the land use near the mass transit station, no? So that's another layer. But what for the purpose of this discussion or this presentation, I will just focus on what sample can the network analyst do, no? Or what kind, no? So this is one example. This is accessibility analysis, very helpful for transit-oriented development. You can apply this in, for example, if you want to test this in the different stations here in Manila and check whether they are really accessible, no, for pedestrians, no. And of course, the network analyst also has other capabilities. It can also analyze traffic data, some origin destination data. So there, it's very powerful, and I think especially for local government units, this is a very practical tool. Now that a local public transport route plan is required, no? So it's being required by law. Now all the LGUs have to develop their own local public transport route plans. And I think there are components of the plan which will need certain analysis in spatial data, no? Of course, you have to check, let's say, the road condition, the traffic condition in the area, and so on, no? So it's very practical, it's very interesting, and transport planning has gained really traction in the last few years, no, or last few decades, no. Okay, so the final example of applying GIS in the urban planning sector is when we do mainstreaming climate change adaptation and disaster risk assessment into the land use plans, no. This is actually related to my first example earlier, because at least here in the Philippines, no, it is the local governments are required to mainstream climate change adaptation and disaster risk assessment in their comprehensive land use plans, or CLUPs, no. So it's very intensive in terms of spatial analysis. It's very intensive of using GIS. That's why learning how to use the software can really be essential for things like these, no, especially when it comes to planning, no. So basically, the components of, well, we'll call it CCVA for short, no? That's the acronym na lang. Climate Change Vulnerability Adaptation and Disaster Risk Assessment. Is that we have a set of, well, it's really an entire process. It's it has actually several components, no? There's a whole guidebook on mainstreaming climate change and disaster risk to the plans. But for the purposes of this lecture, and to make things simple, no, in terms of GIS, the main components are we have our hazard maps and we have exposure units. So for hazard maps, these are the good thing about the hazard maps is these are already generated by most of our government agencies, no. So an example of a hazard map is a flood hazard map. Then we also have like a storm surge hazard map, a rain-induced landslide hazard map, tsunami hazard map, and so on, no? So these are hydrometeorological hazards, no? And the good thing about it is that government agencies like Project NOAA, Pag-asa, MGB, FIVOX, they already have generated maps, no? So as for example, I think Project NOAA, they simulate or they do modeling for these hazard maps often, no? And They are available for use. I know it's on their website. And the nice thing about the data is that there are projections, no, for these hazard maps, no. So there's a 5-year flood. For example, there's a 5-year flood map. There's also a 10-year flood map, and there's a 50-year flood map, no. But for this class, we won't discuss the differences between those. Since we have a limited time, basically that, no. So we have these hazard maps or hazard data, and then for the exposure units, so basically these are the units in your local government unit in your city or municipality that are potentially affected by the storms, no. So HLURB categorized it into the population, which also refers to the residential areas, the urban use, these are the other land uses in your LGU. I think the natural resource production areas, so these are the agricultural areas or the crops. And then the lifeline utilities exposure map, and also the critical point facilities there. So they have their own definitions, but basically these are the exposure units. And what you can do is that there are several studies on how to conduct vulnerability assessment. You can use an index method, wherein it's also the similar principle as the land use change simulation earlier, wherein you assign weights to certain factors, that contribute to the vulnerability of a certain unit. There are studies about vulnerability which can be mapped in the GIS, no? So if you know the sensitivity, exposure, and adaptive capacity of a certain area, you input these values into GIS, and then the GIS can process the data and come up with vulnerability maps, or disaster risk maps. Now, in turn, these vulnerability and disaster risk maps are inputs to the land use planning process, no? And it's very important, no, because as you know, for example, what happened in Typhoon Ulysses, Typhoon Yolanda, all these major typhoons, no, it's really essential, no, that we have to take into consideration which areas are most vulnerable and what policies or programs should be done, no. But the part of GIS and spatial analysis in mainstreaming climate change is very essential because it shows the exact locations, no, and you can derive hotspots, no. So for example, the areas near the coastline are most potential to storm surge, so things like that, no. And it's really very practical, and I think important, no, for our country to have several studies on these climate change vulnerability and disaster risk assessment, no. But again, the good thing is that since the community of there have been recent developments in GIS here in our country, and yes, the government agencies help a lot, no. They provide spatial data to certain institutions, like to academic institutions, so it's easier to process these hazard data, hazard maps, so that they could serve as outputs, no, in making better decisions, no, for the LGU. These are just some examples, no, on how GIS can be applied in the urban planning sector. But for the purposes of discussion, I think these are enough, no, given our time constraint. And GIS has been really there have been lots of developments in the GIS community here in the Philippines, no. So it's really interesting, and I would suggest, no, as students of this architecture class, it's also recommended, no, if you learn a bit of GIS even after you graduate from this course, no, kasi it's really a nice, I would say, extra skill for you. So there is a market, no, of, I think, GIS specialists out there. So it's nice no, to learn this skill, especially now that you're still young, if you're students of this architecture class. And it's apart from being practical, it's also very essential. No, so we can do a lot with location data. Lots of analysis and research can be derived from our location data. So there, wrapping things up, the next, I think, 2.5 sessions no, will be handled by Sir Mix de Rosario. He will focus on QGIS since this software is free, no? And he will teach some basic techniques and tools no, using the software. Okay, so that's it. I'm sorry if my discussion went a bit technical, but if you want to learn more, uh, you just feel free to email me. No, I think I put the email here. If you want to contact me, no, regarding my lecture, or if you have any other questions, no. Okay, so that's it. Thank you so much, class, and yes, Sir Mix will handle the next lecture now. Okay.
Thank you very much, Dr. Mallari, for a very interesting presentation on the basics of Geographic Information System. For those who have questions on Dr. Mallari's lecture, please send them through the link shown on the screen. Our next speaker is Mr. Miguel Fernandez del Rosario. Mr. del Rosario is a geographer with leadership and operational experience in GIS cartography, geospatial analysis, remote sensing, graphic design, and science research. He is a business development and marketing officer in Geospectrum Marketing Services and the vice president of Geospectrum Analytics Services. He graduated from University of the Philippines, Diliman, with a Bachelor of Science degree in Geography and is currently taking his Master's in Geography in the same university. In today's webinar, Mr. Del Rosario will give us an overview of Geospatial Technologies and will walk us through exercises on the installation of quantum GIS and familiarization with its interface. Let us now welcome Mr. Miguel Fernandez del Rosario.
Hi, my name is Miguel del Rosario. You can call me Mix. And this is my portion of the GIS Workshop 101. For today's part of the workshop, I'll be continuing what AE has been sharing with us regarding GIS and geospatial technologies. Let's have some further appreciation of the technologies that enable us to more easily interact and make sense of geospatial data. I'll then guide you through the installation of quantum GIS, a brief overview of the data we'll need for the workshop, then proceed with a little bit of familiarization with its interface to make sure we're ready for the next days of the workshop. An important dimension of geospatial sciences is remote sensing. Basically, it can be as simple as anybody taking a picture with a smartphone camera, to as complex as arrays of satellite dishes looking for extraterrestrial life in other galaxies. In essence, this is remote observation of our environment utilizing different kinds of sensors carried by a platform. Satellites and aircraft are common platforms for sensors that enable observation of a large portion of the Earth at a time. Common examples of remotely sensed data are the images that you see in Google Maps and free data provided by scientific entities. One of these is the Landsat program from NASA, which has been observing the Earth from space since 1972. There are also sensors that go beyond the visual spectrum, such as synthetic aperture radar or SAR technology, that enable us to see through clouds during nighttime. Derivative products of these satellites include digital elevation models that help us produce topographic maps for urban and regional planning. Another important set of technologies is the GNSS, or Global Navigation Satellite System. Implementations of these include the Global Positioning System in the US, GLONASS from Russia, Beidou from China, and Galileo from the European Union. These technologies are not only used for navigation, but are an integral part in modern land surveying and mapping activities. By strictly adhering to a set of coordinates, we are able to build a database of objects that could then be viewed, manipulated, and analyzed using GIS. The GIS software that we'll be using is Quantum GIS or QGIS. This has been steadily developed by a group of volunteers since 2002. What makes this viable as both a teaching and as a scientific tool is that it is a free and open source software that can be accessed and improved by anyone with an interest in geospatial technologies. While we will only be scratching the proverbial surface of GIS applications in this workshop, QGIS's best traits enable us to perform ever more complex and sophisticated operations that are limited only by our imagination. First, we have to download QGIS. QGIS is available for many different operating systems. Please refer to the workshop materials or the links in this presentation. For this workshop, I will be using the latest long-term release version of QGIS, which is 3.22.4 as of today. Using the latest long-term release or LTR maximizes stability as well as availability of support from sites such as Stack Exchange. While this entire workshop can be used with a QGIS version for Mac OS and Linux, I will be demonstrating the exercises using Windows 10. For exercise data, I will be using a variety of free and freely accessible data. OpenStreetMap is a gigantic collaborative effort by ordinary citizens in mapping the world around us. The map data that is usually used in apps like Grab and Foodpanda utilize parts of the OSM dataset. These include roads, bridges, buildings, and other physical and land use features like train stations and hospitals. Please download the ESRI compatible shapefiles package from the GeoFabric host. For administrative boundaries of cities and provinces, let's use the data hosted by the UN Humanitarian Exchange. Please download the Level 3 and the Level 0 to 2 shapefiles. These represent all of the administrative boundaries of the Philippines from the country down to the municipal or city level. Please take note that this data is very much unofficial and indicative. Please also download the 2022 population statistics from the same website. After installing QGIS in your own computer, we can now open it. There might be multiple entries or versions of QGIS, so please make sure you are just opening the item labeled QGIS Desktop 3.22.4. For Mac OS, you might be barred by the OS from running it for the first time you try. You can try bypassing this by going to your Security and Privacy System Preferences page and instructing your computer to open it anyway. When you open QGIS for the first time, it should look pretty much like this. Before we proceed with the first demonstration, I'll show you the different elements of the interface that you should be seeing upon first run. First, let's check out the menu bar on the top. Let's go to View to see where we can see the panels. For now, we'll only need Browser, Layer, and the Processing toolbox. Next, let's double back and take a look at the toolbars. For now, there are 13 toolbars that are activated and present just below the menu bar. We can move all of these panels and toolbars to our heart's content, but we'll stick with these for now. For the panels, let's first take a look at the Layers panel. This is similar to apps like Photoshop, where you can reorder layers and modify their opacity. The next panel is the main map view. This is where all of the loaded layers can be seen. At the bottom of the app, we can see the status bar that indicates the coordinates or location of the area where you put your mouse in the map viewer. The scale, map magnification, and orientation is also displayed. Rightmost is where you can see the coordinate system that your project is currently using. So this is what QGIS pretty much looks like when you open it for the first time. I think a best practice when starting out with a project in QGIS is to immediately define the name of the project and to save the project. So we're gonna go to project, save as, and then save it in a folder where you have also saved or located all of the files that you will be needing for the exercise. So name it whatever you want and make sure it's saved as a QGZ file and press save. So what this does is save this project file, and it also enables a project home in your browser. So what this does is that it immediately directs you to the folder where you have saved the project. This is very important, I think, for immediately locating all of the project files and data that you would need in your project. Nevertheless, you could still use the browser to go to the different areas of your computer, but to make it easier, doing it this way would be, in my opinion, much faster. So let's try to add our first map data. So in our data folder, I have saved the Philippine Administrative Boundary shapefile, which we have downloaded earlier. So you could open that and see this shapefile. So there are many ways to add this to our map. Simplest is to just drag it to our map view there. So you could see it could take a bit of time to load the file. It depends on the size and complexity of the shapefile or data that you are adding to your project. So as you could see, administrative boundaries of the Philippines have been added to the map, and you could also see it in the layers. Another way to add it is to drag it to the layer, to the layers panel. So there, it's also added another layer. Another way is to just right click the layer, or the file rather, and to add the layer to the project. So this is another way of adding your files to the project. As you can see, QGIS has assigned an arbitrary color to all of the new layers that you are adding. So it really doesn't matter if you add the same file multiple times to your project. So there are a variety of reasons why you would want to do that. But for now, let's just remove them. So I'm just selecting two of these, any of these, right clicking, and we could remove these layers from our project. So we've removed this from our layers panel from our project, but it doesn't mean that we have deleted it from our system, from our computer. This only deletes it from the project. So we've already added our first data for this exercise. Let's uh, look around the panels, the toolbars of QGIS and see the basic features. So I think another good practice for anybody using any kind of GIS software is to save the project. So what this does when you save the project is to save what you were just looking at, what you are just looking at. So it saves the zoom level, the coordinates, where you were looking at, as well as the order of layers in the layers panel. So let's go through the other buttons. So first, for viewing the map, we have the pan map tool. So we can already see when we click and drag the map, we can move around. The next one is the zoom in. So just clicking it uh, on any point so you could zoom in more and more. And we could also drag to zoom into a particular area. Of course, we also have a zoom out button, and you could just click to zoom it out. The next one is the zoom full tool. So what this does is that it zooms to the entire extent of our workspace. The next one is zoom to layer. Since we only have one layer, this serves the same purpose as the zoom full tool. We also have another handy tool. So this is called spatial bookmark. So we use this to set up a bookmark for a viewpoint that we like for visualization. So this is useful if we're moving between multiple areas and we want to move between them quickly. So we could zoom in, for example, here around Mindanao. We could set a new spatial bookmark. We could name it Mindanao. And we could save it in our project bookmarks folder and then save it. So we could then check our spatial bookmarks. So for example, I could move around, simulate moving around to another area, but we want to quickly go back to Mindanao. So click show spatial bookmarks. So this opens to the left side our browser, this folder called spatial bookmarks. So we stored it in our project bookmarks folder. So we could select Mindanao here, our bookmark, right click, and then choose zoom to bookmark. So there, we've zoomed back in using the correct zoom level. So for example, I zoom back in, zoom in further, and then using the bookmark again. So we're back at the zoom level that we specified when we saved that bookmark. So another quick tool or another quick technique, you could hold the middle mouse button instead of going back to the hand or the pan map tool. So we could just hold down and drag along using the middle mouse button to move around the map. We could also use the middle mouse wheel to zoom in and to zoom out. We could also see that the coordinates are changing here, down below, when we move the mouse around. So say we want to find a particular area and we have the coordinates for that. For example, we want to go to where the UP College of Architecture is in this map. So let's fire up Google Maps, for example. So I already have the college here. So if we want to find the coordinates for this, we could just right click in the vicinity, and the coordinates would show up. So clicking this would immediately save to our clipboard. But notice the format that it is currently using. So this number format is the same as to what QGIS is using. So this is decimal degree format. So we have numbers here with a decimal point. So one of these represents the latitude and the longitude. But this is inverted. So this is using an inverted format that QGIS might not understand, or might send you to a different area that it's not here. So I've just switched this. I've just switched this in Notepad. So instead of 14 and 121, we could switch it to 121 and 14. So this is what I did in Notepad. I switched both of them up. So I could just copy that again to our clipboard and then go back to QGIS. And then, for example, I could just zoom into a different area and then input those coordinates and then press enter. It would transport us to this area. So maybe you might not be very familiar with the administrative outlines of the Philippines. These administrative boundaries have attributes that dictate um, which city or municipality they belong to. So our next tool is here, the identify features. So you could click that, and you could see that another panel has showed up here on the right side. So if you click any of these features, so we call them features, each of these distinct polygons. So for example, if I click this one, where QGIS has brought me when I entered the coordinates of the college. So if I click that, so it highlights this distinct polygon, and we could see the different features and their respective values. So what we're going to look at now here is the ADM3 underscore EN attribute or feature, and we could see that the corresponding value for that area is Quezon City. So right on the money. So we could just click around for these other features, and we could see the attributes or the feature values changing. So for example, this one is the city of May Kawayan in Bulacan. So we could also identify that it is part of Bulacan and Region 3 by checking all of the other attribute codes here. So maybe you don't want to click around using the identify features tool. We want to see the names of all of these. So we could go to the layer properties here in the layers panel, right click the layer that we're using, click properties. So all kinds of different layer properties will show up. But for now, we'd want to add labels to our layer. So right now, it has defaulted to not showing any labels. So let's choose a single labels. So this will use one of those attributes, one of those feature values as our criteria for displaying a single label for each of those features. So it has defaulted immediately to the ADM3 underscore EN. value. So we could try applying it immediately now. So when you click apply, we already see that the attributes for the ADM3 underscore EN showing up for all of these distinct polygons. So these are our different municipalities here in this general area. So there are a lot more options that you could use here and modify. You could change the font size, you could change the font or the typeface and the styles. So let's keep it at that for now. So there. So you could pan around the map. It might take a while to load depending on the data that you have and the performance of your own computer. But we could see that QGIS is actively labeling all of these individual features, individual polygons, individual administrative boundaries. So as you might have already peeked at, you could also change the properties or the symbology of each of these individual polygons. So for example, we could change the fill and outline of these municipalities and cities. So by clicking this simple fill property, we could change the fill color. So by clicking that, we could go around the color spectrum, the color wheel, pick another color for that, change the stroke or the outline of all of these boundaries, change the width of the stroke. So we could change it to something much thicker, like 2 millimeters, and apply it. So there, we could change the colors of this particular layer. So yeah, let's change it back to maybe a little bit more subtle here, there. So maybe this might still be a bit too difficult, especially if you're uh, not familiar with all of these cities or all of these places and you want to see something more tangible. So we do have the other data that we've downloaded, but those are for the next workshop. For now, here's another trick that we could use to see all of the places. So we could add an XYZ tile. So this requires an internet connection. For now, QGIS defaults to loading an OpenStreetMap XYZ tile. So let's try to load this and see what this would do. So let's add the layer to project. So there. So it's loading an OpenStreetMap map or web layer. So this is a web layer because it requires internet access, and it queries or it calls a web server with this OpenStreetMap data. And when you zoom in, you could see the data layers or the map features changing according to the map scale. So here we could, if you're more familiar with road maps or with other features like, for example, hospitals or schools, so maybe we could locate, for example, the College of Architecture here. So as you've seen, because this new layer is on top of our administrative boundaries layer, it has superseded that and thus obscured that layer that was below that. So we could rearrange that. So again, the administrative boundaries is on top. If you want to see them both at the same time, we could change the symbology again, change the simple fill and the fill color here to something that doesn't have any fill or any color. So we could just change it to no brush and then apply it again. So there. So the outlines still remain, but the we could see now the OpenStreetMap layer. So there are other XYZ tiles available. For example, you could search and add another XYZ tile that uses the Google satellite imagery. So in effect, you could have your own Google Earth in this QGIS application in your own project. And in the end, you could print it, including uh, the QGIS, the Google Earth or the OpenStreetMap layer with your map. So this is the exercise for today. We'll proceed with other more advanced topics in the next session. So thank you very much.
Thank you very much, Mr. Del Rosario, for a thorough discussion on geospatial technologies and detailed demonstration on quantum GIS installation and interface walkthrough. For those who have questions on Mr. Del Rosario's lecture, please send them through the link shown on the screen. This is also the same link to the feedback form which you can fill out in order to receive a certificate of attendance for day 1 of the workshop. For those who wish to attend days 2 and 3 of the event, kindly register through the link shown on the screen. To all our participants today, thank you for joining us for day 1 of GIS Workshop 101. We hope that this session has spurred your interest in Geographic Information System, and we hope to see you on the second day of the workshop on March 15 with the following topics. To all our speakers and participants, thank you and have a nice day ahead.